Mhm. The thing is, when you have this situation, first ask yourself, can you make the problem less complicated? Don't like some problem you cannot do anything, just go ahead, apply the quotient rule. But this one, as you see, you have negative, negative, and a number 3. So we're gonna simplify it first before we find the derivative. I know it's gonna get messy, as you already tried, right? So we're gonna simplify. So the f of x, I'm gonna factor negative 3 out of this, the top 2 terms. So it's gonna be negative 3 multiplied by x plus 1 divided by 2x plus 9. Okay. And then I would treat this as a constant multiple. First, we're gonna find the first derivative. So the f prime gonna be the derivative of negative 3 times x plus 1 divided by 2x plus 9. Since I said we're gonna treat this as a constant multiple, I take negative 3 out of the way. So at least I don't have to deal with the coefficient 3, all right? The quotient rule, we identify the top as a high, the bottom as a low. Sam, could you help me with the high and low function derivative, please? If the high is
So
x plus 1, the low is 2x plus 9.
so the high derivative would
Mm-hmm.
be just 1.
Very good. And the low derivative is?
That would be just 2.
Very good. So how about the quotient formula? The derivative, the quotient rule formula?
That would be low high. Isn't it low high prime minus high low prime?
Low d high
Over
minus high d low.
and then over low squared.
Low square. And
And
then don't forget we have negative 3 out front. Okay.
yeah, negative 3. Okay.
Mm-hmm. So then gonna replace the value that you already told me here. So negative 3 quantity, the low is the quantity. Don't forget the grouping symbol. So 2x plus 1, the d high is 1, minus the high, the quantity x plus 1, times d low, which is 2, all divided by the low square, which is the quantity 2x plus 1 quantity square. So far, so good.
Yeah.
And then we're going to distribute. So 1 times anything is just the same thing. But the second term, the second group, we're going to distribute 2 in there. We have negative 3 out front. The numerator is 2x plus 1 minus 2 times x minus 2. Okay, don't forget that we have negative sign for the entire group. And then all divided by 2x plus 1 quantity squared.
Oh, so the negative 2,
Yeah,
it's
because
because of the negative in front.
right. Yep, the grouping symbol is very important. So when you distribute the 2 in there, it has the sum, right? The 2x plus 2. But you still have to distribute the negative sign to both of them.
So technically you're multiplying x plus 1 to the negative 2 first. So it would be like, oh no, not negative 2, to the positive 2. So it'd
To
be
the
x,
positive 2.
so it'd be 2x plus 2, but then you got,
Uh-huh.
then after that you do the order would be the
Ne-
subtraction is
right. Because you have
distributed.
negative sign out front. So you distribute the negative sign to all terms in the grouping symbol.
Okay.
All good?
Mm-hmm.
Now, so we have 2x minus 2x cancel. 1 minus 2, that is negative 1, right?
Mm-hmm.
So far we have, this is the f prime or the first derivative as negative 3 multiplied by negative 1 divided by 2x plus 1 quantity squared. Or you can rewrite it as 3 times 1, that's 3. Negative and negative multiply to be positive. And I'm gonna write it as 3 over 2x plus 1 to the power 2. So far, this is the first derivative, but you are going to find the second derivative. That means you're gonna find the derivative of what you just got, right?
Mm-hmm.
Uh-huh. When you have this one, you can use the, what do you call, the quotient rule, as it looks like the quotient form, or you can see this as, I'm gonna write in different color. So 3 as a constant multiple multiplied by 2x plus 1 to the power negative 2. You see what I did? I just changed from positive power to the negative power, but in the reciprocal form. Why I would do this? Because I avoid using the quotient rule, but I'm going to use the general power rule with the constant multiple. This constant multiple, and this one I'm going to use the chain rule, or it's called the general power rule. Okay. So
That's chain rule.
is the chain rule is the general name for the general power rule.
Okay.
The general power rule, that means you see the power of the function. So that's why you kind of mix and match. You still refer to the power rule, but at the same time you treat them as a composite function. So far you're okay?
Yeah.
All right. And since is 3 is the constant multiple, I just take it outside of the derivative, get it out of the way, and work on the main piece, which is the power negative 2 of the quantity 2x plus 1. And the general power rule, just recall the function g to the power n, right? When you find the derivative, it's going to be n multiplied by that function, and the power reduced to be n minus 1, and then multiply by the derivative of that function. Okay, that's the general power rule. For our case here, the n is negative 2, that's the power. The function g, which is the inner function, is 2x plus 1. And what is the g prime?
That would be just 2.
Just 2. And then for this portion, we're going to use the general power rule. We get 3 multiplied by negative 2 as the n, multiplied by the quantity of the g to the power negative 2 minus 1 becomes negative 3, multiplied by the g prime, which is 2.
I have another question.
And
So
let's finish up real quick. 3 times
sure.
2 times 2, that's negative 12, right? Negative 12. And the negative power becomes the reciprocal, or 2x plus 1 to the power 3. So this is your second derivative.